going to look at creating our first RBD, but instead of creating an RBD from scratch, we're going to use a system hierarchy coming from another RelaySoft application. So we select the database, my database, and we are in BlockSim interface. We now want to, if we want to create an RBD, we go to RBD, right click, and we got the options of an analytical RBD or a simulation RBD. The analytical RBD enables us to model the system up to the first failure. The simulation RBD enables to model the system at any time, including maintenance and repairs operation. So we keep things simple, and we'll be looking at creating an analytical RBD. But we don't use this window. We go to this insert pull down menu, and we can see here the type of analysis we can carry out. And we select instead build from RelaySoft application. We select this left one. And that gives us the option of using data from RCM or XFMEA as a base for our RBD, or otherwise from Lambda Predict. So we're going to use RCM XFMEA as our base, and we'll be using the power steering FMEA that we develop in another video. And we'll be creating an RBD. We then want to create sub-diagrams, and we click OK. We click Next. We leave everything selected, and we now click OK. Okay, so the software is reading the data being developed in XFMEA, and we can see here in the first system level, we can see all the items that we inserted in the XFMEA, in the FMEA of the power steering pump. We can see with the reservoir, the inlet and outlet hose, the pump housing, and so on. But these are sub-diagrams, in so much that we double click, they refer to the causes that we've inserted during the FMEA. So for this exercise, what we want to do, we want to convert these blocks into, instead of sub-diagram, we want to convert them into standard blocks. And to do that, we right click on the block and we go convert standard block. Okay, so that changes our sub-diagram reservoir into a standard block reservoir. And we'll repeat this operation for all the other. Once we've done that, and we've deleted all the other sheets, our RBD is made out of 6 blocks, which are the main items, into one single RBD page, which is the power steering pump. At this stage, if we click on each one of them, there is no information about reliability. In fact, the reliability simply says cannot fail. And that is because we haven't got a function assigned, a reliability model assigned. We got the name, but we don't have the reliability model to assign. To do that, we click on these clicks, and we are then left with a choice of any one of these models to insert. Say, for example, we select a 2-parameter wobble distribution, and we have the scale parameter, the shape parameter. Say, for example, we leave 1.5, and our scale parameter, we put, say, for example, 15,200, and then we click OK. So that will become the model for our reservoir, and we click OK. So we've assigned the reliability model, which we can verify down here. We repeat this operation for all the others. Once we've done that, and we can see we got functions on every block. Some of them are wobbles, some of them are log normal, some of them are exponential, and so on. So we characterize every part of our system. We can now click on the first icon to analyze, and we can see the graphical output. So the first graph is the unreliability, and then we can click on the second one, which is the reliability as a function of time, but we should have changed it perhaps as a function of kilometers. And we can look at the distribution of our failures, and we can look at the failure rate. So if we are then interested in collecting more detailed information, we can use the quick calculation path and say, for example, what is the reliability after 18 months. Okay, so the program functions exactly like Weibull, because effectively what we characterize here is a non-repairable product. In this case, it's a non-repairable system. So in fact, our analysis stops at the first failure. There's no repair associated to each block. In subsequent video, we'll show also how to characterize our blocks so that they can be configured for repair distribution and any other information that could be needed.